Hello everyone, I welcome you all in this course titled Digital Logic and Circuit Simulation. In this lecture, we will discuss about implementation of Boolean function through suitable size multiplexer. If the Boolean function is given, how we implement through a multiplexer, Here, suppose the Boolean function is given as what? F of w x y z. Suppose this is given as what? This is given as x complement y plus z complement. Suppose this is the Boolean function, then first find in what min terms the output of this function is 1. So, for finding, we know the process of finding the canonical SOP, or simply we can say that standard SOP for. So, first we will write, means the function is written in a standard SOP form, means we can write the min terms in which the output value is 1. So, for determining which particular combination the output is 1, this function is a combination of two terms x complement y and another is a term is z complement, and both are together. This means the function is in SOP form. Then we can write it in a standard SOP form, means we can write a function, we can write a min terms in which the function value is 1. How we write a function min terms in which the value of the function is 1? Simply first term is what? X complement y. This means here the value of x and y are fixed. When this is written as w x y z in sequence, out of these variables, Boolean function is a 4 variable. This means here the value of x is 0 and y is 1, which is fixed, means when we assign the w and z 0 0 0 1, this means 4 possible combinations are there, out of which x y is fixed in all 4 combinations. This is 0 1 0 1 0 1, that value is fixed, and rest the value of w and z are changed 0 0, whether both are 0 0, or this is 0, this is 1, or this is 1, this is 0, or this is 1 and this is also 1. When this means this particular represents a min terms m2. Similarly, this represents a min terms m3, this represents a min term m10, and this represents a min term m11. When another term is what? Z complement. Again we write a sequence of Boolean variables w, x, y, z, in which the value of z is fixed, means that is 0. What are the possible value of w, x, y, z? This is 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Out of which here the value of z is fixed, means 0 in every min term. When binary convert, this is corresponding to a min terms 0, similarly min terms 2, this is min terms 4, this is min term 6, this is min term 8, this is min term 10, this is min term 12, and this is min term 14. When we write, if one of the min terms that occurs more than one time, then we simply write it in one times and other occurrences of that min terms are ignored. Here this is written as summation of what? We start from here 0, 0, 2, then 3, then 4, 4 is written here, 3 is here, then 6, 8, 10, 11, then 6, 8, 10, 11, 10, 11, 12 and 14. Means in these particular min terms, or we can simply write this is nothing but what? This is m0 plus m2 plus m3 plus m4 plus m6 plus m8 plus m10 plus m12 m11 plus m12 plus m14. This means the function is written in a standard form, a standard SOP form, and we can, after that we find in which min terms the output value is 1, and then simply select how many number of variables in a Boolean function. So, one is a general representation, not a efficient way of representing a Boolean function by using a multiplexer. in general way of implementing, we simply take a multiplexer of size. Here we take a multiplexer of size. What we take a multiplexer of size 16 cross 1. Here we know that in these particular combination the output value will be 1, and then here then we simply after that we design a multiplexer which is used to implement this Boolean function, means we implement this Boolean function by using a multiplexer. Here let us suppose there are 4 number of Boolean variables. How many variables? Boolean variables to represent this function, there are 4. This means general way of representing it through a multiplexer, we take a multiplexer which is of size 16 cross 1. 16 means here that is I0, I1, I2, I3, I4, I5, I6, I7, I8, I9, I10, I11, I12, I13, I14 and I15. Total 16 inputs are there, I0, I1, I2, I3, I4, I5, I6, I7, I8, I9, I10, I11, I12, I13, I14 and I15. One output is there, output that is Y. How many selection lines are there? The selection line for representing a Boolean function in a general way, general multiplexer used to represent a Boolean function is a what? 16 cross 1 in that cases, because 16 cross 1 multiplexer is required. This means 2 to the power 4 cross 1 means 4 number of selection lines are there, and these selection lines are named as what? W, X, Y and Z, and this is what? Nothing but a 16 cross 1 mux. This value is, now the question is what are the minterms? So simply we can assign the input corresponding to the minterms. The minterms m0, m2, m3, m4 and so on presents to represent a function. This means we assign corresponding to minterms 0, which one is the output? I0, means when the value of w, x, y, z are 0, 0, 0, this means I0 is selected as a output, and whatever the value of this input I0, that is the output. Means in this particular minterm is present to represent a function, means this assign a value 1. Similarly, this 0, then 2, this also assign a value 1, then 3 assign a value 1, then 4 we assign a value 1, then 5 simply 0, 6, 1, then 7, 0, 8, 1, 9, 0, 10, 1, 11, 1, 12, 1, then 14, 1 means 13, 0, 14, 1 and 15 also 0, and this is also 0. So simply this is the general way of representing a Boolean function corresponding to the minterms. We simply provide that particular input corresponding to minterms, we assign a value 1, and rest of the input which are corresponding to which the minterms are not present in a function, we assign a value 0. This is a general way, this is not a specific way or not a suitable size multiplexer to implement a Boolean function. In this way we generally represent a Boolean function through a multiplexer. Now what is the efficient way of representing a Boolean function by using a multiplexer? So generally when we talk about a general way is what? General way is we use a, suppose there are n variable Boolean function containing, suppose the Boolean function containing n variables, then simply the general size of multiplexer is 2 to the power n cross 1 mux, and we know that 2 to the power n is the number of input, 1 is the output, and n represents the number of selection line, and based on the selection lines simply we provide the which particular input is selected as a output. This is depends on the number of selection line, and which min term value is 1, this is based on a selection line, and the min terms present in function we simply provide the input corresponding to that min terms value is 1 and rest inputs are 0. This is one way to represent a Boolean function by using a multiplexer, but what is the efficient way to implement a Boolean function? Generally efficient way to implement a Boolean function by using a suitable size multiplexer. So, when we talk about a suitable size multiplexer for implementing any Boolean function, and suppose the Boolean function consisting n number of variables, n variable Boolean function, then what is the efficient way of representing our suitable size multiplexer? Suitable size multiplexer is what? 2 to the power n minus 1 cross 1. Suppose we represent a function f of w x y z, that is written as suppose w x complement plus y complement z. This means what is the suitable size multiplexer? Here the number of variables used to represent Boolean function that are 4, then simply we use 2 to the power 4 minus 1 cross 1, this means 2 to the power 3 cross 1, that means 8 cross 1 is the suitable size multiplexer. Similarly, for representing a 3 variable Boolean function, suitable size multiplexer is what? Suitable size multiplexer is 4 cross 1. Similarly, for representing a 2 variable Boolean function, suitable size multiplexer is what? 2 cross 1 and so on. So, here the first n minus, in case when we implement a function by using a suitable size multiplexer, then the least n minus 1 bits or most n minus 1 bits, n minus 1 variables, least n minus 1 variables or most n minus 1 variables of the function are connected to the selection line. Either we connect a least n minus 1 significant bits are connected through from a selection line, or simply n minus 1 most significant bits are connected through a selection line, and rest 1 bit is remaining. Either when least n minus 1 bits are n minus 1 variables are connected through a selection line, then simply most significant variable is remaining, and B supply most significant variable either in its original form or complemented form, or some input values are 0 or some input values contains a 1 through a input lines. And this is the way of representing Boolean function by using a suitable size multiplexer. Here the remaining single variable of the Boolean function is used for data inputs. Generally n minus 1 most or least significant variables are used to represent a selection lines of multiplexer, and 1 remaining variables of Boolean function is used for data inputs. Data inputs means that is supplied through a input of the multiplexer, and if the single variable of data input is denoted by x, then each data input of multiplexer will be the x, either x goes through that input or x complement means goes through that input, or simply 0 goes from some input or 1 goes from. Now the question is which input goes x and which input goes x complement and which input value always 0 or always 1. How we determine this value? So for determining this, we simply implement a Boolean function through a implementation. First make a implementation table for suitable size multiplexer and then represent a Boolean function through a suitable size multiplexer. Here make a implementation table to implement a Boolean function using mux, and those min terms which are present in a Boolean function are circled in a implementation table. Suppose we want to represent or implement a Boolean function, so the min terms, when we write a Boolean function in a standard SOP form, the min terms present to represent a Boolean function that are circled in a implementation table. Then again when corresponding to a particular column, both min terms are circled, then 1 is supplied from corresponding data input. When corresponding to a particular input column, both min terms are circled, then what 1 is supplied from a corresponding data input, and when corresponding to a particular column both minterms are not circled. This means 0 is supplied from corresponding data input, and when corresponding to particular column only upper minterm is circled, then simply x complement is supplied from corresponding data input, and when corresponding to a particular column only lower minterm is circled, then x is supplied from a corresponding. Let us take it by a example. Suppose we want to implement the function f of w x y z is equal to summation of 0, 3, 5, 6, 9, 10, 12, 15 using suitable. This means this function is given a standard SOP form, means in these particular minterms the output is 1 and rest minterms the output is 0. One way is used to we use a general method to be use a 16 cross 1 multiplexer to represent this, just like as a previous example, but here suitable size multiplexer is what? There are 4 number of variables in this Boolean function, hence suitable size multiplexer is what? This is 2 to the power 4 minus 1 cross 1, that is equal to 2 to the power 3 cross 1. This means here 8 cross 1 mux, and this 3 represents the number of selection line. Here suppose the functions are the Boolean functions, Boolean variables are represented by w x y z. Here w x y z, first 3 least significant bit that are taken as a selection lines of this multiplexer, or b, if we want, then we also take the first 3 most significant Boolean variables are taken as a selection line, and this is a z is taken as a z variable is goes through a data line. How it happens? Suppose let us take, we implement this, we make a implementation table in which, because this is represented 8 cross 1 multiplexer, this means how many number of input? In case of 8 cross 1 multiplexer, there are 8 inputs starting from I0, I1, I2, I3, I4 and I5, I6, I7. These are the, what happens when simply, this means I0 means these 3, because here we simply, this is a 8 cross 1 mux, there are 8 number of inputs that are named as I0, I1, I2, I3, I4, I5, I6 and I7. This is the output y, and there are 3 lines are used as a selection line, because this is a 8 cross 1 mux, 8 cross 1 mux. Now these in a implementation, this is what? This is a implementation table. So all the inputs of the suitable size multiplexer are represented through a column in a implementation table, and then 3 variables x, y and z, here 3 least significant variables are taken as a selection line, and one most significant variable that is represented by a w, it goes through a data line. So here this is written as what? First is written as w complement, and then second row that represents a w. W complement means when w complement is 1, when w is 0, and when w is 1, when w is equal to 1. So this means here case w is 0, then this means I0 that is represented through, this means this is what? X complement, y complement, z complement. This is x complement, y complement, z, that is 0 0 1. Similarly x complement y, z complement 0 1 0. Similarly x complement y, z. Similarly this I4 represents what? When the value of, means when this supplied 0 1 0 0, that means I4 is selected as a output. This means here that is x, y complement, z complement. Similarly I5 x, y complement, z. Similarly I6 x, y, z complement, and I7 is selected as a I7 input is selected as output when the value of x, y, z are 1 1. Now the question is, what is here when w is 0, this represents a 0, when all 4 bits are 0 0 0 means that is w complement x complement, this represents a min terms, w complement x complement y complement z complement, this means this represents a m0. Similarly 1, next is 1 because that is what w complement x complement y complement z, that means 0 0 0 1, that is 1. Similarly 0 0 1 0, that part 2 3 4 5 6 and 7. Then when w is 1 and this is I0 means x y z value are 0 0, this represents a 8. Similarly when w is 1, this is 0 0 1, that represents a 9, this 10 11 12 13 14 and 15. This is what? This is a implementation table. After making a implementation table, all the min terms which are used to represent a function, Boolean functions, are circled in this particular this implementation table. Here we see that which min terms is present when we write a Boolean function is in a standard SOP form. 0 3 5 6 9 10 12 and 15 are circled. Here 0 is present, this means this one is circled. Then second one is 3 is present, 3 is circled in this table. Then 5 is present, 5 is circled in this table. 6 is present, 6 is circled in this table. Then 9 is present, means 9 is circled in this table. 10 is present, 10 is circled in this table. Then 12 is present, 12 is circled in this table, and 15 is also present, 15 is circled in this table. Here what are the rules? Here we see that when corresponding to a particular column, these are the inputs are simply written as in a column I0, I1, I2, I3. So when in a particular column corresponding to I0, when both min terms corresponding to I0 are circled, then simply one goes from that particular input. In case of when variable Boolean function is represented through a 8x1 multiplexer. Here these are the rules. When corresponding to a particular input column, both min terms are circled, then 1 is supplied. When corresponding to a particular column, both min terms are not circled, then corresponding data input is what? 0 is supplied. When corresponding to a particular column, only upper min term is circled, then x complement is supplied. Here in place of x we write a w. This means here what happens here, this is the case, upper is circled, then this means simply what value goes from I0, this means this corresponding to w complement, this I0 when we see the row w complement and input column I0, we can see that this 0 is circled only, not w is circled, this means we can write this w complement. W complement goes through I0. What happens here? Only lower is circled, lower min term is circled corresponding to I1 in this particular column. This means W goes from this input line I1. Similarly, when we talk about I2, this column, see this column, again lower min term is circled and upper is not circled, then again W goes from this. When we see this, this means only upper is circled, this means W complement goes from this. Similarly, when we see this, lower is circled, this means W goes from this. Here corresponding to I5, only this upper is circled, this means W complement goes through this particular input. When we see this particular column corresponding to I6, 6 is circled, this means again W complement, and 7, 15 means I7, what the lower min term is circled, this means here W goes from this. Then we implement circuit, they implement Boolean function. Here what is W? This is taken as W, this is taken as, then we apply a NOT gate here, this is what? W complement. So for input I0, what we have to supply? W complement. W complement is taken from here, this is supplied to I0, I0, next one is W is supplied here, W is supplied here, means through I1 W is supplied. So, W complement is supplied from I0, then I3 we simply here I3, this means W is also supplied here I3. Then next is again I5 and I6. So, this is I5 and I6, W is supplied. Rest W, rest W are supplied here. This is from taken from W is taken from here, and we supply a W from I1, W from I2, we supply W from I4, that is W, and I7. This is the circuit diagram of implementing a Boolean function by using a suitable size multiplexer. So, here suitable size multiplexer for any Boolean implementing any Boolean function that containing a n Boolean variables, suitable size multiplexer is what? 2 to the power n minus 1 cross 1. Here n minus 1 least significant Boolean variables are used to represent a input like as I0, I1, I2 up to I7, and rest one most significant bit, that here in this case W is used to represent a data input, means through a data input either W goes or W complement, we simply input W complement through a input, or W through a input lines, or 0 through a input lines, or 1s through a input line. Now, what happens when suppose here in an implementation table we make another implementation table of the same function here. Suppose let us take the implementation, we already design an implementation table of given Boolean function. This is the implementation table of given Boolean function. Here in implementation table, what we have to provide through input I0, whatever the value of W, its complement goes through I0. Then now what happens here, suppose we simply see the value of the input W, X, Y, Z, suppose this is given as 0, 0, 1, 1. Here we see that this particular min term is present, this means the output is 1. We see what is the output here. Here what is the value of W? 0. W value is what? That is 0. This means complement goes here, this is W is what? W is 0. Complement 1 goes here, this means W is 0, W goes from here, W is 0, means the value of W is 0, W goes from here I1, I2, I3, I4, I5, W is from I1, I2, I5 and I7, and W complement 1 goes from here, 1 goes is what? So, what are the first we determine the value of this 0 1 x y z, the value of x y z is 0 1 1 1. This means 0 1 1, this means this is corresponding to input I7, I3, not I7, this is a what? I3 we see that I3 is connected from what? W complement. So, what is the value of W is 0, this means its complement goes 1. So, this means what is the value of I3, W complement goes through I3, this means the value of output is what? Whatever is the value of I3 is 1, this means the value of Y is 1. Similarly, when we see that 0, 0, 1, 0, 2 is not present in during the representation of this Boolean function, this means what will be the value of this? These are the x, y, z. Simply this represents what inputs? Means the value of selection lines are 0 and 0. This means I2 input is active, and that goes to a output. I2 is the output. Now question is, what is the value of I2? So here W is what? W is 0. This means here I2 is connected from W, and W is 0, this means the output of Y is what? That is 0. In this case we determine what particular combination the input is 0 and the input is what input combination means for what value of w x y z the output value y is 1 and the output value y is 0. So, after that we will find that in these particular combination the output value is 1 and rest combination the output value is 0. Let us take another example. Suppose we want to implement this Boolean function f of w comma x comma y comma z, that is simply written as what this is written as, suppose x complement, and this is written in a standard SOP form. So, first we write a function, it is in standard SOP form. So, here written as w x y z, that is what here the value of x is fixed 0 and these are changeable 0 0 0 0 0 1, then 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. All 8 are here, the value of this is fixed 0 0 0 0 0 0. This means this is the min terms, this represents a min term what, that is min term 0, min term 1, min term 2, min term 3, min term 8, 9, 10, min term 10 and this is min term 11. This is nothing but a, simply we have to write 0, 1, 2, 3, 8, 9, 10, 11. This is the minimized form is written and then we convert it into a standard SOP form, means when we write a output of this function, then in this particular combination min terms the output is 1, rest combination the output is 0. Suppose we want to make a, first we make a implementation table here, and what is the suitable size multiplexer, since the variable function containing a 4 Boolean variable, this means 2 to the power 4 minus 1 cross 1, this means 2 to the power 3 cross 1 is a suitable size multiplexer, suitable size mux to implement this Boolean function. In 2 to the power 3 cross 1 means 8 cross 1 mux, that is simply designed as what, 8 cross 1 mux, and there are 8 inputs. And this is I0, I1, I2, I3, I4, I5, I6, I7, one output, that is Y, and here most significant 3 bits, these 3 bits are taken as what? Taken as a selection line. This means here least significant bit Z goes through data inputs. So, either generally we take any 3 variables that represents a selection line and one remaining variable which goes through a data lines, but generally we either take a least significant bit as a data input or most significant bit as a data input. Here in that case, in first case like here, we take a most significant bit that goes through a data inputs and rest 3 least significant bits are taken as a selection line. Here we just take another example in which we take a first 3 most significant bit as a selection line. So, what are the selection line here? The selection line are W, X, Y, and the variable Z means this is the least significant variable that goes through a data line, and then we simply make a implementation table here. So, when we make a implementation table here what the inputs are represented through 3 selection line, means when the value of W, this is what, I0, I1, I2, I3, I4, I5, I6 and I7. Here this I0 when W, X, Y, W, X and Y all are 0 0, this is what W complement, X complement, Y complement, similarly W complement, X complement, Y, similarly this represents W complement, x y complement. Similarly, this I3 is represented by w complement x y, I4 is w x complement y complement, I5 is what w x complement y. Similarly, I6 is what w x y complement, and I7 is what w x y. This means when here in this multiplexer, when w x y both all are 0 0 0, this means I0 input is selected. Similarly, when 0 0 1 I1, similarly 0 1 0 I2 and so on. And then what is the written here? First row represents for a z complement, means when the value of z is 0 and when the value of z is 1. So, when the value of z is 0, this means that represents the input minterms what? W all are 0, W x y and z all are 0 0, which represents a minterm 0. We write this minterm 0, we simply put 0 here. Then this is what? When z complement, means z complement is 0, this is nothing but a 0 0 1 0, this means that is 2. This is what? 0 1 0 1 0 0 0 1 0 0, this is nothing but a 4. Then simply this is what? 0 1 1 0, that is what? 6. Similarly 8, then 10, then 12, and this is written as 14. What happens here? When z is equal to 1, this is written as 1. When this here 1, this is written as 1, 1, that means 3. This is when z is 1, in this case I2, that means this is written as in case of this means w complement x, y complement, and z means when here 0 1 0 1, that is 5, 1 3 5 7 9 11 13 and 15 are written here. Now, the minterms present in a representation of Boolean function in a standard SOP form whose values are 1, that are circled in this implementation table. So, here for circling the minterms in this table, what minterms is present? 0 is present, 1 is present, we circle this one, then 2 is present, 3 is present, circle this, then another is 8 is present, 9 is present, here 9 is present, then again 10 is present and 12 is present. Suppose we simply represent this function is what? That is another term we also include with this function, that is what? W complement W. Suppose we implement here the W complement x y and z complement, and one term is also suppose w x y and z, means the function is represented. Then what happens means the two minterms, all this particular term containing all the literals, means that is represented as 0 1 1 0, this is nothing but a m6. We also include 6 here, 3 0 1 2 3 6, and this is what? W x y z, this means 1 1, this is means 1 1 1 1, that means that is 15. So, 15 is also included here. Now, two extra minterms are added in this table. What happens? This is just for learning something. This means we circle 6 also and we circle 15 also. In this implementation table, we see that in a column corresponding to input I0, both minterms are circled. This means this is what? In this particular input, 1 is provided as a input I0. Similarly, both column corresponding to input I1, both minterms are circled. This means 1 goes from this input also. Here both are not circled, this means 0 goes through this input. Upper is circled, this means z complement goes through this input. Both are circled, 1 goes through this input. Both are circled, 1 goes through this input. Both are not circled, 0 goes through this input, and in column I7 means column corresponding to I7, only lower is circled, this means z is goes through this input. Here we add a 2 extra minterms, that is m6 and m15, that for only in this particular column the lower minterm is circled, and in this particular column upper is circled, means some input we simply provide a value 1, for some input we simply provide a value 0, and for some input z complement, and for some input z. So, here let us simply what happens here, suppose z is taken as data input, this is what z complement, and when both are z and z complement are connected through a z and z complement both are connected through a OR gate, simply produce a output 1, and when both input z and z complement are connected through a AND gate, this simply produce a output 0 always. Now, the question is what I0 1 goes, 1 means 1 goes through I0, similarly 1 goes through I1, same 1 goes through I1 also, then 0 goes through input I2, I2 is what, this is 0, 0 goes through I2, then z complement goes through I3, I3 is what, z complement, simply this is z complement goes through I3, then similarly I4 1, here this is 1 and I4 we simply connect it with this particular input I4 1, I5 is also 1, this means simply I5 that is also 1, I5 1, then I6 0, this means the 0 is connected from here, I6 is 0, and then I7 that is Z, Z is supplied from a I7. In this way, this is the way of presenting or implementing Boolean function by using a suitable size multiplexer. Here the Boolean function containing a 4 number of variables, hence suitable size multiplexer is 2 to the power n minus 1 cross 1, this means 2 to the power 3 cross 1, and this is general way to represent a Boolean function. And when we see that what is the, when the value of w, x, y, z, that is what happens, suppose we just check for one input, that is 1 0 1 1 11. What is the value here, w, x, y are taken as, this means this represents a input number I5, I5 here I5 is this, and what value goes from I5, I5 is connected to 1, 1 is always goes, means in this particular combination the output is what, the output value of y is equal to 1. What happens when we take a some min terms which is not present here, like as a, when we take a 5, when we take that is 0, suppose the value is taken 0 1 0 1, what is this I2, and here we say that I2 is connected from 0, this means the value of y is equal to 0. In this way we make a implementation table and then represent a function through a 8 cross through a 2 to the power n minus 1 cross 1 multiplexer if the Boolean function containing n variables, and generally we also use a 2 to the power n cross 1 multiplexer, the min terms which are present in a function simply corresponding to that particular input, simply we provide a 1 and rest we supply a input 0. And so this is all over about implementation of Boolean function by using a suitable size multiplexer, and in the next class we will discuss about some other topics. Thank you very much.